Okay, let's get started. Today I'm going to talk about 3D programming basic knowledge for 3D programming to make such kind of parrots animation. This is not GIF animation. This is WebGL rendering. So yeah, today's agenda is at first summary and vertex, index, shader, matrix I will introduce, and let's start about it. Okay. Okay, and first summary is all we need in 3D graphics is, I think, shape and color. So I want to give you a rough explanation of that. To make shape and color using vertex, index, shader, and matrix is, I think, basic. So I want to talk about it. At first, vertex. Vertices. Okay, let's start from 2D. When I was a very beginner of 3D programming, I thought we need edge or face to render 3D graphics, but actually we need only vertices. So if we give two vertices, GPU renders one line. So we add more vertices. It's difficult to see, but there's a line in the bottom. So there's actually two lines by three vertices, and we can draw a triangle by saying to the GPU render triangle. And what I want to say is everything is basically vertices. And let the GPU fill in the vertices. This is the message of this slide. And next section, index. Actually, vertex, all we need is basically vertex. But what if no indices in 3D world? For example, square is 4 vertices. But we need 6 vertices to draw a square by only using vertices. It's complicated to explain, but well, we need to draw one line. We need to give 2 vertices, something like that. So as a result, we need to give 6 vertices. And main intention is reference. Index intention is reference. By using index, we can reduce the number of vertex. Let's see, vertices has only 4 points, but actually indices has a reference to 6 points. As a result, we could reduce the number of vertices. So, in short, indices helps to reduce size, and indices are smaller, basically smaller than vertices. So it's helpful for performance. And including me, I was really confused by there are a lot of indices in 3D programming, but main intention is always reference. Okay, next slide. Shader. Many people will confused by shader. Shader will be difficult in 3D programming, but I think it's easier than matrix. And in modern 3D programming, we always need shaders. And to make the explanation simple, let me talk only about vertex shader and pixel shader. Pixel shader is formally in OpenGL fragment shader, but in this explanation, please let me use pixel shader. I think it's easy to understand. And this is a rough pipeline of how GPU is rendering 3D world. At first, as I explained before, we need to give vertices to GPU, that is vertex buffer. And then GPU starts something fixed, constant some kind of processing, and then vertex shader will run, and then GPU constant processing, and then pixel shader run, and as a result, pixel shader generate pixel, so we can get frame buffer, and we can see something in the display. And vertex shader is main idea of vertex shader is make vertex awesome, and this is a vertex shader. We are now thinking about WebGL, and WebGL is basically determining JavaScript. So GLSL, we need to write another language to write vertex shader, and this is a language, but it's in JavaScript, so we need to write in JavaScript string, but it's only 3 lines. Simple one is only 3 lines. We need to calculate position in simplest vertex shader. So we can change, we can modify the shape in vertex shader. For example, we give negative value of position. We can flip the shader, triangle, or something like that. We can modify the shape in vertex shader. And next, pixel shader. Main idea is make pixel awesome, something like that. So pixel shader is almost same with vertex shader, but output color. So it's just output only 1001, so only red. So everything is red. So we can change color like that by position. For example, we can change the color for each pixels. And the important thing is we cannot change position in pixel shader. We cannot change where to put the color in pixel shader. This is key to understand what is pixel shader. And small recap is vertex shader is called by each vertices, and pixel shader is called by each pixel. So this is also important to understand. For example, if let's say we will do 3 points. In this case, vertex shader is called 3 times, and pixel shader is called 3 times because only 3 vertices and 3 pixels. So as a result, this. But we think about triangle. Vertex shader is called 3 times, but pixel shader is called a lot of times. This is different. Difference. And the recap is vertex shader is called by each vertices. Vertex shader mostly gives shape. Actually, like modern 3D programming has more features, but basically, I think this is basic of vertex shader. And pixel shader is called by each pixels, and pixel shader finally gives color. Okay. And the next, I'm not sure I can finish this slide in time. So, but matrix is, maybe you know matrix. You are using matrix, but this 3D matrix is a really strange way. But okay, let's start. Finally, 3D. We will in the previous slide we think about only 2D, but let's start 3D. And to start 3D programming, let's use 4x4 matrices. And we in 3D programming we call this 4x4 matrix affine matrix. And in this section, we will see a lot of matrices. However, the key to understand is just multiply, as you know. And okay, let's challenge to make draw cube. And finally, we give 3D position in vertices. 3 by 24 vertices. But wait, we don't have 3D display or 4-graph. So how to display 3D world? So as you know, we have 2D display. So the answer is project world to 3D world to 2D. To do that, we need camera. So I will explain 2 matrices to describe the camera. At first, projection transformation. This makes near object bigger and far object smaller. But this is actually not correct, a rough explanation, but maybe it's good too for beginners. And the shader is really easy. Just getting projection in the third line and multiply that. Simple. And calculating perspective matrix, projection matrix is sorry, out of scope, so please see the textbook. And just call utility function like this will be safe for you, your first line. And shader uniform, I need to explain. Shader uniform is a communicator to pass matrix of some values to shaders. And this is an example of shader uniform in JavaScript. And as a result, we got this picture, but I'm not sure this is cube or not, just 2D square. The reason is our camera is inside of the cube we gave. So let's escape from the cube. And this is view transformation. In short, we need to give position to camera. This is view transformation. And this is the same. We need to multiply in shader. Shader is simple. And we need to consider about handedness. In 3D engines, we have left-hand coordinate and right-hand coordinate. And OpenGL, we need is right-hand coordinate. And in right-hand coordinate and in 3D programming, camera's front direction is different. In left coordination, front of camera is plus z-axis, but right-hand coordination, minus z-axis is front of camera. Okay, so as a result, we want to move back from cube, so we will give 0, 0, 10 to camera. So to give the camera, we have some kind of utility function, like in this side, mat for from translation is such kind of function, but actually we need invert. That explanation is difficult. So let's pass. And as a result, we will get this. It's probably cube. It's not feeling like cube. So next, we'd like to move object. Okay. So model transformation. Finally, we can move object, and it's a foundation of 3D animation. And this is a shader, same as before. Just multiply, get vertex, get matrix, and just multiply. And in the next step, let's draw more object, 2 objects. That is easy. We can simply draw code twice, but give different matrix. From that, by doing that, we can draw multiple objects. And let's animate. This is a JavaScript code, but by this change, we can finally draw rotating cube. This is a basic animation. And we have. In addition, I'd like to say some kind of a little bit technique. In generally, in textbook just of 3D programming, they explain affine matrix is combination of translation and rotation and scale. This is general explanation, but it's for me it's very black box understanding. So we don't know what is in the matrix actually. And in the game industry, I worked in the before. I was taught by this understanding. In model, there is model coordination. Model has rotation, and model has x-axis, y-axis, z-axis, and also model has position from global origin. And actually, this matrix, model matrix, is a concatenation of x-axis, y-axis, z-axis, and position. Very simple. So you can use it from this value to get position or matrix directly. Very simple. Oh, we have a time. So Okay. Okay. So let's start about it. I made some kind of demo scene. So today, let me explain that. Show that. Yeah. Okay. This is no texture. Everything is voxel, not pixel. Everything is cube, so we can animate. Thank you, Akiba-san. Thank you.